Okay, so the next question was about atomic physics, and we were looking at the energy levels. And so you had an energy line, so we had an atomic line spectra, and we had an energy level diagram being shown. And it tells us this is for a hydrogen atom, and these are the corresponding ones. And then the question said to determine the energy of a photon. Okay, so we're looking at the energy of a photon of blue light with 435 nanometers. Now, again, I've seen that nanometers, so I've immediately written to myself 10 to the minus 9, so I know to change that unit is emitted. Now, again, we know the energy of a photon equation is equal to E is equal to hf. In this case, I've actually got the wavelength rather than the frequency, so I'm going to do hc over lambda. Okay, h being Planck's constant, so I multiply in 6.63 times 10 to the minus 34. C, because again it's a photon, it's travelling at the speed of light, so 3 times 10 to the 8, and then simply plugging in my answer for my wavelength that I was given before, remembering to change my units, which gave me 4.57 recurring times 10 to the minus 19, so giving it to two significant figures. Giving it to 4.6 times 10 to the minus 19 joules. Okay. The next one then said at the bottom was the question was saying identify with an arrow labeled B the transition of the hydrogen spectrum that allows to give rise of the photon ending in A. Now with this you basically wanted to look at the difference in energy. Okay, so the change in the energy between what is equal to about 4.6. Okay, so kind of doing a subtraction from 5.4. Now the IB actually was accepting 3 different answers for this one. I personally would have gone with the second one, as that was closest to my answer of 4.6 here. But they were accepting any of these 3 drawn, okay, so from 0.65 to 5.4, from 0.87 to 5.4, or 1.36 to 5.4. Okay, those were all the ones that would give us a range in that 4 point something joules. You also had to get a mark for showing the arrow going down because it is losing energy. All right, so you could have had those transition, this transition, or this transition here. And again, I've just written down showing what the energy levels are. This is the one personally I would have gone with because it was closest to mine. But like I said, the IB and their mark scheme actually accepted either of those 2 answers as well. But personally, I would always go with the one closest to my answer. So this one here. It then says explain your answer. So here I just said the energy of the photon, E equals hf, is the difference between the energy levels. The arrow is going down as it's energy lost by hydrogen, and the energy is being released as a photon. So the idea that it's dropping down in the energy levels there. So 1 mark for saying what the energy was. So energy difference was equal to the energy of the photon. And 2nd mark explaining why it was a transition going down, because it's a photon being emitted, so the hydrogen is losing energy there.